Okay, now let's further understand this top-to-down design approach by using these further examples. So first of all, this is a car example. As you can see here, we have used car as the main system. And let's suppose that you want to just make a digital car system that can control the different mechanisms of the car. So if we take car as a single unit and we try to develop a system as a single unit, then it would be too complex to do that. So for simplicity and to better understand the system of the car, we can break down this car system into 3 submodules. As you can see here, engine system, brake system, and fuel system. And these submodules are further subdivided into some simpler submodules. You can see here, these are further subdivided into simpler submodules. So we will start from engine system. So engine system, as you can see, is itself divided into 2 submodules, oil system and accelerator system. So what we will do, we will start to research about this engine system, and we find that this can be easily broken down into 2 subsystems, oil system and accelerator system. So we will first make a program for the oil system, and then we will proceed to make a program for accelerator system. And when we will be done with that, then the whole engine system will be completed. Then we will proceed to brake system, and after doing some research, it can be find out that the brake system can be divided easily into 2 subsystems, brake controller and brake oil system. And so goes with the fuel system. Fuel system can be divided into these 2 subsystems. So in this way, we can break down the whole big project of digital car mechanical system into these subsystems, and even these subsystems are further broken down into some simpler subsystem. So in this way, we can make a big digital car controlling system. Now, in the next slide, there is an activity that I want you to perform. So you should first understand what is going on here, and then what specific task is required for you to do. Then you should do that part. So here you can see that, but first of all, let me tell you that maybe the question is asked like this: you may be asked to make a top design approach or a structure chart by giving you some algorithm or flow chart at first. Normally, it happens that we make the structure chart before algorithm and flow chart and program, but in reality, it may be the case that you are given these things at first, and you may be asked to extract or make a structure chart from algorithm or flow chart or a program. So you may be asked in the reverse order as well. But here, the scenario is given to you, and you have to complete this structure chart. Here you can see that the system is alarm app. So the main module we have is alarm app, that is further broken down into 3 subsystems, which are set alarm, check time, and sound alarm. So we will start from set alarm, and set alarm, as you can see, is further broken down into set time. Set time means that like if you want to be awake at 6 a.m. in the morning or something like that. So you will first program this submodules for set alarm, set time, and then you will proceed to turn alarm on or off. So we will program these submodules for set alarm, and then we will proceed to check time subsystem. As you can see that it is left as it is, and this is what is expected from you. You have to complete this submodule, and you should break down this check time submodule into sub modules. But before that, let me tell you about the sound alarm submodule. So sound alarm module is broken down into 3 submodules, in which the first submodule is play sound for 2 minutes. Okay, then check off or snooze. Snooze here means that to pause the alarm. It doesn't mean that you are dismissing the alarm, but you are pausing alarm for some time, like for 10 minutes, and then the alarm will ring again after 10 minutes. Okay, so we will start by making program for play sound for 2 minutes, then we will proceed to snoozing, and then finally reset or clear alarm. It means that it is similar to dismissing the alarm. Okay, so in this way, if we make the small programs for these 3 submodules, then the sound alarm submodule will be completed. So now what you have to do is to break down this check time submodule into some simpler module. So how can you do it? Think about it. Okay, let me guide in this regard that what is check time? Look, let's suppose that you have set alarm at 10 p.m. and you want to awake at 6 a.m. in the morning. So what will happen during this time? That you have set alarm at 10 p.m. and you want to ring this alarm at 6 a.m. in the morning. So what will happen until then? So you have to think on this thing. So I can give you a hint that it will check the time after every minute. It will take the time from your mobile phone, the time from your mobile phone, and compare that time with the time that you have set for the alarm. Let's suppose that right now it's 11 p.m. and you take this time from the mobile, 11 p.m., and you compare it with the alarm time, that is 6 p.m. If both match, then the alarm will start to ring. But in this case, as the time are both times are different, so the alarm will not start to ring. So in this way, every minute the alarm app will check the time, take the time from the mobile system and compare it with the set alarm time. And if both time match, then the alarm will start to ring. So you can break down this check time submodule into 2 submodule. One to take the time from your mobile system and then compare it with the set alarm time. So I have given you the underlying process of check time. Now I want you to complete this uh, structure chart by breaking down this check time alarm into subsystem. Okay. So in this way, in this video, we talked about top to down design approach using structure charts, that is breaking down a bigger problem, a bigger set of instructions into some simpler manageable sub problems.